For my next example, I have a system, meaning two equations. What I'm going to be looking for is their point of intersection. I'm going to solve by graphing again. Put it in mx plus b. What's great is my top one's already in the form mx plus b. We'll get this one here in a minute. In the form mx plus b, notice again, start at my y-intercept. 1, 2, 3, 4, 5 is my starting point. The coefficient of x is my slope. I need to make it a fraction. When I make it negative 3 over 1, that's my rise over my run, meaning down 3, run 1. Down 3, run 1. There's my equation. The more of those points I put, the more likely it is that one of those dots is my answer. Now, for my other equation, I need to solve for y. I need to get it in mx plus b first. Minus 3x to each side gives me y equals, I can't combine them, it's not going to be a negative 5x, negative 3x minus 2. So when I come over here to graph, mx plus b starts at negative 2. There's my starting point, my intercept. My m, negative 3 over 1, means rise, negative 3, run 1. Rise, negative 3, 1 run. And we've got kind of a problem because what's happened with these two lines is that they're parallel. And remember, parallel means they're never going to cross. But what am I looking for an answer? I'm looking for where they cross. The problem is, when these lines are parallel, I'm going to have no solution. Not that that's a bad thing, it just means there's no point that they're ever going to share. There's no ordered pair that's going to work here that's going to work here. And that's perfectly fine. Now, here's what's going on. Maybe you may have noticed in the equation, another definition of parallel are lines equal distance apart like railroad tracks. 5 feet, 5 feet, 5 feet, 5 feet. All those ties are the same distance apart because if any of them ever got thinner, the train would not be able to move forward. If any of them ever got wider, the train would fall between. They have to be the same distance apart in order to be parallel. Well, that's what's happening. Having that same slope is what made that down 3 over 1, down 3 over 1. That's what's holding these two lines parallel, is having the same slope. But let's come back to that here in just a minute when we look at our next example.